Hi everyone, welcome to my latest video, or if this is the first time you've watched, just welcome. Sometimes people ask me what my interests are within the ham radio hobby, and that's a little bit difficult to answer. I'm a DXer, contester, builder, station builder. I enjoy a lot of different things. I guess I enjoy a good challenge, and if I had to choose one term to describe my activity in ham radio, it would probably be explorer. I love to explore new things, especially challenging bands and activities that are maybe a little bit out of the mainstream. One thing I've been interested in for about 30 years is the 3 centimeter band, or 10 gigahertz. I always thought it was beyond my means to get on that band, and it probably is, but I'm not always the most reasonable person you'd ever hope to meet. Sometimes I try to do the unreasonable. So I'm attempting to get on the 3 centimeter band. And primarily I'm trying to get a terrestrial station together to work tropo and rain scatter and so on. And I've got a lot of the pieces for that, but it's not fully together yet. But I got a little sidetracked with the idea of getting on 3 centimeter EME, or moon bounce. I was on 2 meter moon bounce and 70 centimeter moon bounce years ago, and had a lot of fun with that back before digital modes when everything was CW. Just totally loved it. And I think the whole idea with 3 centimeter EME got started when I stumbled into a 6-foot dish, or a 1.8 meter dish, which is big enough for EME on that band. I was asking around locally for an old dish network or DirecTV dish, something small like a 1.5 half a meter dish to play around with for the terrestrial stuff. And I got an email from a ham who only lives about 8 miles from me and said he had a 6-foot solid aluminum microwave dish in his barn that I could have. Well, I was just shocked. I live in rural Maine. You don't find that kind of stuff around here. So I went and got this dish, and it's laying out here in my driveway, and I've been thinking about EME ever since. EME is really a crazy goal for me. It really is, probably is too expensive for me to even think about, but I really have not been able to stop thinking about it. So along the way, I heard that a lot of people are experimenting with receiving 3 centimeter EME using a small satellite dish, something on the order of a half meter to a 1 meter dish, and an LNB, which you use on the dish for what it's intended for satellite work. LNB is basically a low noise block down converter. It's basically the dish feed that goes out in front of the dish and collects the signal coming from the dish surface and amplifies it and down converts it in frequency into the UHF range. Well, these can be used for receiving the 10 gig ham band, especially the 10.368 gigahertz area of the band that's used for weak signal sideband and CW and digital modes and so forth, including EME. And so an LNB will convert 10.368 gigs down to 618 megahertz, which is within the range of a lot of simple SDR receivers, including the $25 to $30 RTL-SDR USB sticks, which is what I have. And so I decided to try this. And so I ended up getting a 76 centimeter dish and a couple different LNBs to experiment with. And this is a video about my progress and results so far receiving 3 centimeter EME with such a simple system. There's at least one LNB out there that will work for this right out of the box to some degree. They have a little problem with frequency stability. Some are far more stable than others, and there's at least one that is stable enough to work sometimes for receiving digital EME signals on 3 centimeters out of the box. Sometimes it gets a little drifty and it doesn't decode for a few minutes, and then it settles down, and it does. But there are modifications you can make to these things to make them a lot better, and some are easier to modify than others, and I'll talk a little bit about that in this video. So I've rambled on long enough, and you've certainly stared at my ugly face long enough, so let's just get into it, and I'll show you some of what I've done with this so far. Here is my small dish setup for experimenting with receiving 10 gigahertz or 3 centimeter band EME signals. This is a 76 centimeter offset dish, which I picked up on eBay for $109 shipped. It's a WineGuard DS2076 dish. And a Bullseye 10 kilohertz LNB here. The dish and LNB are designed to mount together, so no work to do installing the LNB. I did add a bore sight here, this aluminum tube, and it's attached to the support arm for the LNB with a simple bracket I made up. It's kind of a pie-shaped bracket there that's just taped onto the support member for the support tube for the LNB. And the bore sight is adjustable. Maybe you can see the slot here by loosening this nut. I can slide this back and forth to adjust the azimuth direction of the bore sight a little bit. Or by loosening the two nuts, I can move it up and down to adjust an elevation a little bit. And if this dish were perfectly peaked on the sun, when I've got this little plate mounted behind the bore sight here, I'm just doing this with one hand because I'm holding the camera. But it's not perfectly peaked right now. It's not peaked in elevation either. But if it were, this shadow on the plate down here would be perfectly focused and symmetrical. So I peaked the dish on sun noise using a measurement setup, and then adjusted the bore sight while it was peaked on sun noise. So when this little assembly here is off, which I can't do with one hand, but it just clips on there and comes right off, then I can sight through the tube here to see when I'm pointed at the moon, as long as the moon is visible, of course. So that's all there is to the dish and LNB setup. You'll see there are two pieces of coax going into the LNB here, and I'll get into that later. One is the LNB signal output and also where the DC power goes in. The other is an external 25 megahertz reference from a GPSDO to get rid of any frequency drift in the LNB. And I'll be getting into that in a later portion of the video. So I just have this very crudely mounted, all of this part here, from the dish down, this arm and this bracket comes with the WineGuard dish. I added this aluminum plate as an interface to mount it to a back assembly unit from an old, I think it was a DirecTV dish that just simplifies mounting on this mast I've got here for a crude setup to be able to aim this dish. For azimuth, I've just got a friction slip arrangement on the mast that it's mounted on, so I just kind of push or pull the dish wherever I want it. There's also a fine azimuth adjustment screw on the back side of this unit over here, but I'm not really using it. I can aim it accurately enough in azimuth just by slipping it around the mast. And then this is a fine elevation adjustment. By turning this screw here, I can adjust the elevation very finely, and I use a ratchet wrench to do that with. This is a coarse elevation adjustment, and every hour or so I have to loosen this bolt and pivot the arm here up or down to do a coarse elevation adjustment so that I don't run out of range on this here. A very crude setup, but it does work for receiving 10 gigs EME signals. And in other sections of the video I'll go into more detail about some of the other aspects of this system. So let's talk a little bit about LNBs for receiving 10 gigs EME with a simple dish. This is an Avenger LNB. These are very cheap on eBay or elsewhere. And Bob Atkins, KA1GT, has an article on his website about how he modified one of these to use an external frequency reference to get rid of the drift. These just have a crystal oscillator, and they drift too much for actual EME reception, decoding of digital signals, and so on. So Bob went into some detail about how to modify one. It's a bit of a process. It's not really too difficult, but it might be tricky for some. These just have the one connector here, which is where the The IF signal comes out of the LNB nominally at 618 megahertz for 10.368 gigs. And also where the DC power goes in to power this. So to modify it, you need a second connector to run the external 25 megahertz reference in from a stable source, such as a GPSDO. So there's a little bit of work. I have one here that I modified per Bob's article. And here you see I've added the second connector. I had to grind away some metal on the internal assembly to put an SMA connector on there, mount the SMA connector, and then kind of hack the plastic to get the cable out for the external 25 megahertz reference to go in. Internally, and I won't go into a lot of detail, it is on Bob's website, you have to remove this this crystal. This is the 25 megahertz crystal that was in there. So you have to remove that and then add a very tiny chip capacitor and chip resistor from the added SMA connector over to one pad of where the crystal was mounted. So it's not difficult, but I'll discuss a somewhat simpler LNB to modify here in a moment. I just have the penny here for a size reference. Let me get this out of the way. So I used one of these Bullseye 10 kilohertz LNBs, model BE01. These are more stable out of the box. These have a tiny TCXO inside, so they're a lot more stable. They only drift a couple kilohertz out of the box, which with one of these unmodified, I was able to receive EME signals. I was able to receive the DL0 SHF EME beacon reasonably well, but it is a bit of a pain trying to keep track of with the drift on these. So you see this has two connectors. It has the green color-coded type F connector here, which is where the IF signal comes out and also where DC power goes in. It also has the red one, which is connected to the TCXO output pad internally through an attenuator. And they suggest that you can monitor the actual frequency of the TCXO by connecting a frequency counter here. So anyway, that simplifies modification a little bit, because here, all that's necessary is to go in and remove the internal TCXO. That's the entire modification to use an external reference with this one. And I'll insert some pictures of what the inside of this looks like and the TCXO and so forth here in a moment. But the device that you have to remove is just this one rather tiny little device here, and the camera is not going to focus on this particularly well. But as you can see, it's quite a small device. It has 4 surface mount solder pads, one on each corner. With hot air desoldering, it comes out of there pretty easily. Just heat it up and pluck it out. I did have to remove the circuit board from the little metal housing in the LNB to get this out, because the metal was heat sinking it too much and I couldn't get it hot enough. Removing that, once you've got the thing apart, is really very simple. You just use a soldering iron and some solder wick or a solder sucker to desolder the 2 center pins of the F connectors from the circuit board, and then it just lifts right out. You flip it over and or just apply the heat rather, and pluck this thing right off and put the LNB back together. So more details coming up in another section of the video. Okay, so I apologize for subjecting you to my very messy ham shack, but aren't they all messy? And of course everyone needs a few good clip leads. You just got to have clip leads somewhere in a ham shack, right? So to discuss my 10 gigs receiving setup here in the shack, I've got this little box which I built up. All it is a couple of switches and LEDs and a little 12-volt regulator in here, and this connects here to a little wall wart power supply down there, the little black box. That's a 12-volt DC unregulated wall wart rated at about 1 amp. The nice thing about it is it actually puts out, because it's unregulated, about 17 volts if you don't draw too much current from it. And that allows polarization switching on the LNB. So the power comes into this little box. Here's an on-off switch. Obviously that's off, that's on. And with this switch in the position where it is, that's vertical polarization on the LNB. If I flip it to the other position, that's horizontal polarization. Now, I don't recommend using horizontal with these LNBs for EME reception because the noise figure on them on the horizontal probe is not as good as on vertical. But for purposes of experimentation, I did want to have both available, and so I wired this up that way. And then the voltage, which is 12 volts for vertical polarization, hence the 12 volt regulator in here, goes out to a bias T or power inserter, which I'll show you in a moment. And for horizontal polarization, they require a little higher voltage, and the 17 volts works fine. So that's what happens when I flip this switch, is it applies the 17 volts that's coming in from the wall ward instead of the 12 volts from the regulator. And that goes over to here. We hams call these little boxes, if I could get the coax out of the way. Like I said, it's a messy ham shack. We call these bias Ts. In the TV industry, they're called power inserters. But it's just DC power going in the F connector on the top from the little box that I just showed you. Coming out the F connector on the right, it's DC and RF. That connects up to the LNB to power it and also to get the IF RF down from it to your receiver. And then this connection over here just goes to the receiver. Now the receiver, in my case, on 618 megahertz is just a little RTL-SDR stick, and I don't know if you can even see it on there, but it's just a simple RTL-SDR stick. I'm trying to get the camera where you could see it. There we go. And amongst all these wires, just plugged into a USB port here. And so that's the actual SDR receiver. Now for the external frequency reference, per the LNB modifications I discussed, I'm using this Leo Bodner GPS reference clock, GPS antenna coming in here, and I actually have an antenna up on the roof, but these come with a little puck style antenna that will work just fine as long as you don't have it in a location where it can't receive GPS satellites. I'm just using a USB cable to power this, 5 volts in. Now the one thing with the Bullseye LNB is these Leo Bodner units have a square wave output, and you want a 25.000 megahertz reference frequency going into the LNB, but the LNB didn't like the square wave, so I added this little mini circuits filter here. This is a 24 to 31 megahertz bandpass filter, model BBP 27 R5 Plus, or 27.5 megahertz, which is its center frequency, I guess. So this is a plug-and-play solution. You could build a 25 megahertz bandpass filter or low-pass filter just to get a clean sine wave going to the LNB, and it locks to that just fine. So here's the cable that comes out, and this is the separate coax that goes up, the white one I showed you out there connected to the LNB for the 25 megahertz reference. So with this setup, there's no frequency drift at all in the LNB. It's now locked down, dead stable, so that it doesn't move anywhere. So that's the hardware end of the setup here in the shack. I apologize for doing this section of the video rather crudely. What I should do is just put some of these photos directly in the video and do a voiceover, but I'm not very good at video editing, and that's going to take forever, and I want to get this thing published, so I'm just going to do this quick and dirty, talking about some pictures that are actually on my my website, my collection of 10 gigs EME progress notes. There's the URL if you want to look this up and get cleaner versions of these pictures. So here's from the first EME reception test I did back in August. This is with an unmodified LNB. This was the Bullseye 10 kilohertz LNB, straight out of the box on the dish, unmodified. And as you can see, I was getting decodes of the DL0 SHF EME beacon. Sometimes, not every time, but sometimes I was able to get it. The problem is that the signal is drifting. You can see the line on the signal on the waterfall here, which is kind of broad and spread out because of the doppler spreading on 10 gig EME signals. or libration spreading, I mean. Sorry about that. But you can see it's slanting to the left, it's drifting. And now in this particular minute right here where the mouse pointer is, it's not drifting too badly. And then the next minute it's drifting like crazy. So this is a combination of Doppler shift, because the moon is moving and it causes the apparent frequency of the signal to move constantly, plus receiver drift. So this was not an ideal setup. A little bit tricky to get everything dialed in and get decodes of the Q65 digital signal some of the time, but it did work. So I had proof of concept that I was on the right track toward a working system there. And I was even able to get a CW file sample. I'm not going to play that. But the CW is extremely weak, and with all of my years of experience receiving very weak signals, I can actually copy the call sign on CW, but people who have less EME experience would probably tell you there's no signal there at all. I have a way too much experience with that sort of thing. Now, subsequently, I did modify the LNB to use an external 25 megahertz reference and get rid of the drift. So I was able to pry this apart without breaking any of these 6 little clips that hold the plastic housing together. You see there's 6 of them here. I was able to reach down through this oval opening around where the F connectors come out of this with a tiny little pick or jeweler's screwdriver and pry these back to open a little bit while squeezing and pulling on the case. And then I was able to squeeze this part of the case right here where the mouse pointer is, and pop these 2 open, and then squeeze a little up here and pop these 2 open. So I got lucky, I guess, but I got this open without breaking any clips. So inside, to discuss the modification a little bit, here's what's inside. There's a little circuit board mounted in there. And this little silver device right here is the TCXO that you need to remove, and it's a surface mount device soldered down to 4 little pads. Now with my heat gun, I was not able to get this out with the circuit board in here, so I had to use a soldering iron and solder wick to desolder this point right here, which is the center pin from one F connector, and this point down here, which is a center pin from the other F connector. And then the circuit board just lifts right out of here. And once it's lifted out of here so this metal is not heat sinking the thing, it only took a couple of seconds to heat this up with the heat gun and pluck this off of here with tweezers. And then of course put the board back in and resolder these 2 center pins of the connectors. So once it's out, you can see now the 4 little solder pads on the PCB where the TCXO was in there. And that's the only modification necessary for this Bullseye LNB to use the external frequency reference. Just pull that one device out. Now the cover, which I don't actually have a photo of, but the metal cover that goes over this is sealed in place with some sort of white silicone goo, like an RTV type stuff. And you do have to, after removing the screws, and there's 5 of them. After removing those, you have to kind of pick that stuff off or slice it with a knife and carefully pry off the cover. It's not difficult, but you know, take your time and pry it off carefully without beating things up too badly, and it comes apart just fine. And obviously when you're finished with the modification, put the metal cover back on here and put the plastic parts of the case back on, and you're all done with the modification. And I discussed the earlier the setup with the Leo Bodner providing the 25 megahertz reference. Here it is when I was testing just on the bench here. So the end result of all that is that in subsequent EME tests, you see I'm getting plenty of decodes of the DL0 SHF beacon. In fact, I'm getting it every single digital mode sequence now. It alternates between the Q65 digital mode on even minutes and CW on the odd minutes. I'm getting every single period decoded just fine here now. And with a combination of the modification of the LNB to reduce drift or eliminate drift because of the external 25 megahertz GPS derived reference, and Doppler shift tracking, which I'll get into in a minute. You see the signal is now very stable. It's a nice vertical line here at 1000 Hertz. It doesn't drift anymore. What a wonderful improvement. And I will get into how I accomplished this Doppler shift tracking here in the next part of the video. Okay, here's a segment about the Doppler shift tracking in the software. I'm listening to the DL0 SHF 3 cm EME beacon, and you can see down here for the first several periods I had Doppler tracking enabled, so it's a nice vertical line on the waterfall. It's not moving in frequency at all because the software was automatically tracking the Doppler shift. Then I turned off that function, and you can see the slow drift down in frequency here now as the Doppler shift is causing the signal to move, or the apparent frequency to change. And it's getting a little weaker because the dish is getting a little off the moon. I haven't been outside for about 5 minutes to move it, but you can clearly see the Doppler shift moving the signal in frequency there. So here's how to set that up. Using WSJT-X and HDSDR for the receiving SDR software, and a program called VSPE for the virtual serial ports needed for those programs to communicate. So in VSPE, I've already got a virtual device here, COM1 to COM2, a virtual pair all configured, but here's how you would configure that if it wasn't. Create new device. From this menu you want to select pair and give it a moment. Okay. Select pair and then click next and give it a moment. Okay, there we go. So now you can choose a pair of available COM ports for your virtual pair. You need to choose 2 different ones. You can see you do have multiple options in here. But let's say I wanted to go with COM6 and COM7 to create a pair. This enable baud rate can be left unchecked. I don't think it does any harm to check it, but it's not needed, so I just leave it unchecked. Then you would come down here and click Finish, and it would create a new virtual pair. I'm not going to do that. I'm going to click Cancel because I already have mine configured for COM1 and COM2. So that's all there is to it in VSPE, and you should get a message saying that they initialized OK. Next, you need to set up HDSDR. And to do that, you come into the menu, Options, CAT to HDSDR, Port, and select whichever port you want over here. It needs to be one of those from the virtual pair, and you can see I've selected COM2. When you click on that, it's going to take you back out of the menu, so you need to come in again to Options, CAT to HDSDR. Whoop, I slipped off it there trying to do this while holding the camera and talking. Baud rate, and select a baud rate over here. I chose 9600. I don't know why, it just looked good to me, but you can probably choose any number of these and it'll work. So once you select that, you're going to be dumped back out of the menu again. It's a bit odd the way this program works that way, but anyway, come into the menu, Options again, CAT to HDSDR. Down here at the bottom there's a little thing that says Activated. Now mine is already activated, it has a check mark next to it, but after you set up the port in those first 2 steps, it will not have the check mark, it won't be activated, so you need to come in here one last time and click Activated to activate the port. And when you do that, you'll be back out of the menu again. Then, in WSJT-X, go to File, File, Settings, go to your radio tab, and for rig you need to select Kenwood TS2000 because the Kenwood cat command language is the language that's understood by HDSDR, so you need to configure WSJT-X to be speaking that cat language. So Kenwood TS2000, select the opposite serial port of your virtual pair. Remember, I selected COM2 over in HDSDR, so here I'm going to select COM1, the opposite one. Set the baud rate the same to 9600. These other options down here can be left on default. And then one more thing over here for a split operation, you need to select Fake It. Now this isn't actually used for a receive-only application like this, but WSJT-X requires Fake It for this Doppler shift function to work. So I'm just going to cancel out of here since I already have all these settings made. Now in HDSDR, if I have a frequency tuned in, such as the beacon frequency, and normally it would be just 024, 10368.024. I'm adding a 300 Hz offset because I have a slight frequency error in my SDR receiver stick, and I know about that, so I'll just dial it in. And so currently down here in WSJT-X in the astronomical data window, I have no Doppler shift tracking. For the beacon, I would just hit full Doppler to DX grid. That's the right choice for a beacon that's not compensating for Doppler on its end. If I were listening to a regular station, I would choose constant frequency on moon. It would be the appropriate setting for that. But for the beacon, full Doppler to DX grid. And at that point, it is automatically tracking the Doppler shift. If you look up here in HDSDR, you'll see the tune frequency constantly changing as WSJT-X is constantly steering the frequency to track the Doppler shift as it moves in frequency. So you see it's changing at about 1 Hertz every second there right now. So that's all there is to it. That's how you set up the Doppler shift tracking with WSJT-X and HDSDR for EME operation. And you'll also notice down here in WSJT-X the frequency is also changing. One other thing I'll point out is that over here in the astronomical data window in WSJT-X, it has your actual SCED frequency, or the nominal tune frequency that you're set to show you what that is. And then of course over here is the actual frequency after it applies the Doppler shift correction. Two other notes to make on this. If you wanted to change the actual receiver frequency a little bit, let's say you found that you weren't quite on and you needed to retune a little bit, you can do that by holding down the control key on the keyboard. And I don't have enough hands free to do this holding the camera, but hold down the control key on the keyboard, and then with your mouse you can go up here and change the frequency. If I was holding down control, this number would no longer be changing. It would stop the Doppler shift correction momentarily. Then I could manually change the frequency, and then when I release the control key, it'll go right back to Doppler shift tracking based on the new nominal frequency that I had selected during that process. Now you might be saying, yeah, but this is digital modes and I just want to do CW, so this doesn't do me any good. Well, yeah, it does actually, because the software doesn't care about the mode. I can come up here in HDSDR and click CW, and lo and behold, look at that. Frequency is still changing, the Doppler shift correction is still working. So you can do this for CW operation too. You just need to run a digital mode program, WSJT-X, to supply the Doppler shift correction. So it does work for all modes. So that's how I'm doing the Doppler shift correction, and I really like it. It makes listening for 10 gig EME signals a whole lot easier when you have this set up and you can automatically track the Doppler shift like that. This past weekend was the second microwave weekend of the ARRL EME competition 2022. And I had clear skies Friday night, so I was able to listen and see what else I could hear on 3 centimeter EME with this simple system. My moon window is only 4 to maybe 4.5 hours long. I need about 20 degrees of elevation to get over the trees in the east, and then I run out of ability to see the moon when it hits 55 degrees elevation because the tower that the dish is mounted on interferes with the movement of the dish. So there weren't a lot of stations that I could listen for during my limited moon window. Activity seemed to be picking up just at the time the moon was getting too high for me and I had to stop. But during this period, in addition to the beacon, I was able to decode 5 other stations on Q65, W3SZ, GB2FRA with a very good signal, IK0HWJ, HB9Q, and OZ1LPR. And GB2FRA had a great signal, even strong enough to be clearly seen in the HDSDR waterfall. So a fine signal from GB2FRA. You can see here I had decodes up to -8 when my dish was peaked right on the moon. And also looking very good in the WSJT-X waterfall there. Nice and strong and bright. And just a sample screen here of some other decodes, just a quick screenshot somewhere during the night. In this one I had decoded HB9Q, W3SZ, and IK0HWJ. So this simple system definitely does work. I have no doubt that if I were to be active over a period of time with this, I would probably decode at least 15 stations, maybe a lot more. I think others with just a little bit bigger dish have decoded about 30 stations with a little bit bigger dish and an LNB, so it can be done. Also during this night, I did manage to receive GB2FRA on CW working DB6NT. And on my website I put 3 audio files here. They're not the best. I do not do very well using SDR for very weak signal CW copy. It's just too awkward to dial everything in and get the filters adjusted for optimum copy, and by the time I do that the signal is gone, especially on a single EME QSO like this. If I had been using a conventional receiver, I'm sure I could have done better. I could have gotten better audio samples, but these 3 are here. I can clearly make out both call signs and Rogers and 7.3 and thanks in these files. So it's better than the one I posted earlier on the beacon. Could have been better if I'd had a receiver that I'm a little more comfortable with. So anyway, this very simple system definitely does work for receiving 3 centimeter EME. And I think it's a lot of fun to experiment around with this and see what can be done as I think about what I can do to get a real system on 10 gig EME. I might be doing some other videos on related 10 gig subjects here in the near future, but meanwhile, I hope you've enjoyed this one, and thanks for watching.